At first, when you look at this problem, you will laugh at it and say this is super duper easy to solve. But beware, problems like this are dangerous because they look harmless, but they hide a subtle trap inside them. Let us first solve it the usual way by simplifying the expression. The numerator is x squared minus 9. This should look familiar because 9 is 3 squared, right? That means the numerator is of the form a square minus b square, or the difference of squares pattern, which we know is equal to a minus b times a plus b. Using this idea, x squared minus 9 can be rewritten as the product of x minus 3 and x plus 3. Once we do this, the factor x minus 3 appears both in the numerator and in the denominator, and so we cancel them. Now what remains is x plus 3 equals 6. Solving this is straightforward. To separate x, we subtract 3 from both sides, which gives x equals 6 minus 3, and therefore x equals 3. Easy peasy. But at this moment, the actual trap is triggered. Do one thing, just substitute x equals 3 into this expression. What do we get? We get 3 squared minus 9 over 3 minus 3, which is nothing but 0 divided by 0. But hey, 0 divided by 0 is not a real number at all. You cannot cancel them and make it equal to 1. It is completely undefined, which means the original expression simply does not exist at x equals 3. Therefore, before solving anything, the first thing we should do is to check the domain, which means finding all the values of x for which the given expression is properly defined. For our case, this simply means identifying the values of x that make the denominator equal to 0 and excluding them right away, because we all know that division by 0 is not allowed. So, the denominator here is x minus 3. For the expression to make sense, this denominator can never be equal to 0. That immediately tells us that x cannot be equal to 3. So, even though the algebraic steps looked clean and logical, the final result is not acceptable. Thus, the final conclusion is that this equation has no solution. Like, share, and subscribe.